Welcome back to our tutorials on classical mechanics. We've got some questions here that two forces F1 and F2 act on a rigid body. The force F1 acts at a point with the position vectors R, and the force F2 acts at the point with position vector R2. A third force, however, will act, this is F3, acting on a body such that F1, F2 and F3 are in equilibrium. So now we've got some questions we might need to answer to find the magnitude of that force. But there are some informations that we need to write down that are missing in this question. We need to write down these two forces, F1 and F2, and we also need to find this position vector R, and we also need to write down F3 and the position vector R2. When we are done with that, then we are good to go in answering the questions of the magnitude of the force. But before that time, I would like to explain a few things about these questions. Of course, this actually relates us to physics because we are talking about forces of an object. But then, when we talk about a rigid body, basically in physics, a rigid body is nothing but a solid body in which deformation is zero, or deceleration, as we call it, deceleration. So deformation of a rigid body must be equal to zero, or what we can say that small it can be neglected. It is so small that this type of amount or energy can be neglected. So the distances between any two given points on a rigid body remains constant in time regardless of external forces or moment exerted on it. So a rigid body is usually considered as a continuous distribution of mass, and that will take us to what the Newton's law of motion tells us. We know we have about three laws. We have the first law, we have the second law, we have the third law. But this question will take our mind back to first law. And what does first law of motion say? It states that an object at rest will remain at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted on by an external force or unless acted by an unbalanced force. Those who are doing physics will know what we mean by unbalanced force. So here we are more interested in what is a rigid body. It is not about the momentum, because if we go to the second law, it should have referred us to momentum. Of course, we know what momentum tells us, that the acceleration of an object depends on the mass. It depends on the mass of that object and the amount of force supplied or applied. So let's look at what is missing in this question. So we would like to have them down. The first thing that we need to write here is F1. We need to write F1, F2, and then we also need to write F3. So in this question, let's have F1. So we have F1. F1 is given as 2i. This is 2i cap plus j. 2i plus j. 2i plus j Newton. This is F1. And then we have F2. F2 is given as negative 2j minus k. Negative 2j minus k. This is F2. And these two forces act on a rigid body as indicated. The force F1 acts at a point with a position vector R1. So let's have R1. R1, this is R1. This is R1. So let's have it down. taking R1. R1 is given as 3i plus j plus k. This is 3i plus j plus k. This is R1. The next information that we need, of course, call this, it is in meters, and the force F2 acts at the point with position vector R2. R2 now is also given as I minus 2j. I minus 2j. So these are the informations that we need in order to answer these questions. So number one, the first question A is asking us to find the magnitude of F3. We need to find the magnitude of F3. Okay, this is the first question, and the second question is asking us to find the vector equation of the line of action of F3. So let's start with the first question. We need to find the magnitude of F3. The magnitude of F3. So first of all, these are the informations that we have. F1 and F2 are these forces. So solution. Let's have solution. Solution. We have 2i plus j. We have 2i plus j, which is the first force. This is force number 1. We need to add this up plus the second force, which is negative 2i. We have 2i plus j. Then we have negative 2j minus k. Negative 2j minus k. That is what we have. Now plus F3. Of course, F3, the third force, we don't have the third force. It is not given in terms of I, j, and k. So plus F3, and this must be equal to 0. This is how you handle this type of questions. So F3 in this case must be equal to the component, this component of I, j, and k. So therefore, making F3 the subject, it means that we need to take this component of I, j, k to the other side. And if we do that, we will simply have negative 2i, because we know we have 2i plus, there is no I here, so we simply have negative, because when this positive crosses to this side, it becomes negative. So we have negative 2i. This is negative 2i plus j, because we know we have j. We have negative 2j. When we take this negative here, it becomes positive. It is 2 minus 1. So this is plus j, because it remains 1, plus j, then plus k, because we know here also k is negative. When we take it the other side, it becomes negative. But the question is asking us of the magnitude, so we need to take the magnitude of these two forces. So F3, therefore, F3, we want to take the magnitude of these two. This is going to be the square root. The square root of whatever we have here, which is negative 2 squared, negative 2 squared plus 1 squared, which is 1, then plus 1 squared also, 1 squared. And if you punch this in your calculator, this should give you 6 newtons, because we know that these things are in newtons. It is given, the first force is in newton, the second one is also in newton. So the final answer to this question is root 6 newtons. Now that will take us to the second question, and the second question in this video, part B, is asking us of if the two forces, we will need to find a vector equation of the line of action, the vector equation of the line of action of R in the form of R is equals to A plus lambda B. So let's have that down and see how that goes. The vector equation. So the second question for us here is to find the vector equation of the line of action of F3. So for us to find the vector equation of the line of action of F3, we need to multiply this position vector R with the forces, and we have R1 and R2. We multiply them with these two forces, and then we are able to find the equation. So we are going to do this. What we need here is the R1, which is the first initial position vector, is given in the form of 3i plus j plus k plus k. We need to multiply this with the first force, which is 2i plus j. 2i plus j. Now we add with the third position vector, and the third one is, the second one is I minus 2j. This is I minus 2j. So multiply this by the second force, which is negative 2j minus k. Minus k. So this is what we have now. The next thing we need to do is we need to add this up with the component of xi plus yj, xi plus yj plus zk plus zk. Add this up with this component and then multiply it by F3 that we just got. And what did we get? We get it was what do we get? We get negative 2i plus j plus k, negative 2i plus j plus k. This is what we get, and we use this to find the magnitude. So multiply these together, and then what we will get, let me use a different color. When we bring all these components together, you will simply have negative I plus 2j plus 2j plus k plus k. Add this up, you get 2i plus j minus 2k minus 2k plus we will have y minus z. Y minus z I plus negative 2z minus x. We are trying to multiply this component xi, yj and zk. This therefore means that x is x, if we'll just a minute, this will give us y minus z. Y minus z is equals to negative 1 as our first equation. Negative x minus 2z is equal to negative 3. And there we have x plus 2y is equals to 1.